Hello, so this video is about finding the quadrant that a particular angle is in. If it's that angle is given to you in radians and it's, the radians are approximate because pi is probably approximated to 3.14 or maybe a little further, but it's still an approximation. So how do you do that? Well, first I want to show you that you should know very well some reference values for angles around the circle. So let me just kind of go through it. 0, 90, 180, 270, and 360. That's in degrees. But in radians, you can have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then finally, you can have where you approximate pi. Of course, you'll still have 0. Here, you'll have 1.57, 3.14, 4.71, and 6.28. And let me just show you where I got these. So, if you take here this pi button, right, I can say pi divided by 2. Here's your 1.57 that I got here. Of course, pi itself, 3.14, and then of course if you do 3 pi divided by 2, and so on and so forth, right? So these are things you should know. Once you know that, and you're asked something like, find the quadrant, sorry about that, when S equals, for example, 1.7 radians, for example. Well, the idea is you look at these reference values and say, well, 1.7 is, I rotated here past 1.57, so I'm probably around here, 1.7, between 1.57 and 3.14. And in this quadrant, quadrant 2, right, X is what? Positive, Y is negative, and you're in quadrant 2. So if I said when S is negative 4.3, okay, that means I'm rotating in the negative direction. So let me just kind of relabel this, make it a little bit easier. This would be 0, negative 1.57, negative 3.14, negative 4.71, and then negative 6.28, because I'm going that way. So now if I'm looking at negative 4.3, that means I'm rotating here. I'm going negative, negative, negative 1.57, negative 3.14, and somewhere in here I'm at what? Oops, I wrote it down. Negative 4.3. Looks like I'm in quadrant 2 again. So I'm between negative 3.14 and negative 4.71. So I would say X is positive, Y is negative, and I'm in quadrant 2. Okay, let's do another last one. Let's say I say when S is 5.6 radians, right? All these are understood to be radians. Okay. Positive, so I keep rotating, right? I'm here, 1.57, 3.14, 4.71, and I'm somewhere here at 5.6 between 4.71 and 6.28. I'm in quadrant 4. So you'd say here X is positive, Y is negative, and I'm in quadrant 4, right? And you just can keep doing this over and over again. And if you have a number bigger than, or a rotation bigger than 6.28, all you want to do is back out all the full revolutions, because you really want a coterminal angle that's between 0 and 6.28. So if I said when S is 17.2 radians. So what I really want to do is say, I want to divide out and say how many sets of 6.28 are in. So how many sets? 6.28 are in 17.2, right? So if you look at that, and you could say, well, 6 times 3 is 18, so you know it's going to be a little less than that. But so here you go, 17, oop, right wrong. 17.2 divided by 6.28. Right, there you go, 2.73, whatever. So you know that what you're trying to do is essentially back out the full revolution. So one way you could do it is this way, is divide and say I have 2. So I would have 17.2 minus, let's say 6.3. I'm going to round this to 6.3. 6.3, right? So you're rounding them out. So here you have what? 9, and then you have there. No, that can't be. Yeah. Okay, 7. So that's 0, and then you have 1. Sorry. And then minus another 6.3. So you have 6. 6 goes in there, 4. So really, finding 17.2 radians is equivalent, or thereabouts, since we did round, to about 4.6. So where's 4.6? Well, we know this is 0, and this is positive. 1.57, 3.14, 4.71, right? 3.14. So you're somewhere in here in quadrant 3, where x is negative and y is negative. Right? So that's the basic idea. You really, if you were to represent 17.2 somewhere, you're kind of doing this. 1 rotation, 2 rotations, and then still somewhere here in this quadrant. And in fact, obviously 4.6 is much closer to 4.71 than 3.14, so you'd probably be somewhere here, right? All right. And then we just throw that. Thanks so much for listening.